All right, another lesson, 7.8, generate equivalent expressions. I hope as you're reading that, your brain automatically thinks equivalent means equal, and you know what an expression is. It's those problems with variables, coefficients, terms. Those are expressions. We're going to generate. Generate means to make. So our objective is I can use the properties of operations to generate equivalent algebraic expressions. Hopefully you have heard of these properties, at least previously. You know operations, that word means addition, subtraction, multiplication, and division. And the properties, I think as I review them, they will sound familiar. So first of all, an equivalent expression are equal expressions. So for example, x plus 3 is equal to 3 plus x. They mean the same thing. It doesn't really matter where I put x and 3, but I can switch them around and they are still equal. That's our goal, is to make equal expressions or equivalent. So here's those properties. Again, I'm sure you've heard of them, but let's just do a bit of a review. First, you have the properties of addition. Now you might say, Mrs. Twisdale, do I need to write this in my notebook? The answer is yes. You do need to write these in your notebook, so go ahead and pause it and start writing them down. Make sure you separate the properties of addition and the properties of multiplication. So, as I explain these, the properties of addition also apply to its counter operation, which is subtraction. They work both ways. And same with properties of multiplication, it works with division as well. So the commutative property of addition, and commute means to move, it affects the order. So if the order of the terms change, the sum stays the same. So let's look at the example because I think that makes more sense. 12 plus a is the same as a plus 12. The order of these terms here does not matter. I can move them in addition and it will not change the answer. So 12 plus a is the same as a plus 12. That's the commutative property, when you're moving the order of the terms. The associative property. Now when I was in 7th grade algebra, we learned associative, and associate is a friend, and so I always thought of it as the friend property because it talks about grouping. So if you think of these parentheses as little friend makers or grouper makers, that might help you out. Anyway, it might have just confused you more. But if the grouping of the terms change, the sum stays the same. So if we have 5 plus 8 plus b, and 8 and b are grouped together, that's okay because they're all being added together. If we have 5 plus 8 and then add b, that's okay as well. With addition, it doesn't matter which ones we do first, as long as the numbers stay the same. Okay, so these, you'll notice they're in the same order, 5, 8, and b, 5, 8, and b, but they just grouped them differently, and that doesn't change the answer when everything's addition. The identity property is when the sum of 0 and any number, it is that number. So 0 plus c is just c. So let's look at the properties of multiplication. The commutative property, again, it's the order of the factors. If the order changes, the product stays the same. 9 times d, same as d times 9. Associative property. If the grouping of the factors changes, the product stays the same. Now that is if all of them are multiplication, like they are here, 11 times 3 times e. So I can move those parentheses around and it won't change it. If I do 11 times 3 first and then multiply it by e, that is the same as this expression here. So this is an equivalent expression to this expression. The last one for identity, for multiplication, in order to have the same answer, to multiply, you have to multiply it by 1. The product of 1 and any number is still that number. So 1 times f is just f. Okay, so here's an example that we have. Here's example 1. Rewrite the expression 2 plus 3k plus 5 with only two, and that's supposed to say terms, sorry it got cut off, with only two terms. So they want us to, pretty much we're going to rewrite it and combine like terms like we did in our 7.7 lesson, but we're going to use our properties to kind of prove what we're doing is true. So if I have 2 plus 3k plus 5, I can first use the commutative property. I can move those numbers around. I can move 2 over here, move 5 over here. I can move it around. I can do 3k plus 2 plus 5. That's the commutative property at work. Doesn't change anything. Now if I take this expression, bring it down here, 3k plus 2 plus 5, if I combine or group these two like terms, 2 and 5, using what we call the associative property, and then I have 3k plus 2 plus 5 is 7. So 3k plus 7. So it's very similar to what we did yesterday, but it's kind of just a proof of why what we did yesterday works, is because of these properties or these rules of operations. We can make 3k plus 7 an equivalent or an equal expression to the expression that we started with. So go ahead and rewatch that. Ask me questions because I know it's kind of new. But again, it's very similar to 7.7. It is just backing ourselves up saying, why is what we did yesterday, why does it work? And it's because we followed the operation and properties rules. Now, the distributive property. This might be new for some of you. Pay close attention because this is new and it is a little confusing, so focus with me. Make sure you write down this definition. The distributive property is multiplying a sum by a number is the same as multiplying each term by the number, and then, let's see if I can find out why we can't see the rest of this. And then adding the products. Okay, so that is our distributive property. Let me show you an example. Yes, you need to write this down because to see it is the best way to come back and refer to it later. So if I have 3 times g plus 9, let me get my laser, and g plus 9 is in parentheses, that's the same thing, an equal expression is 3 times g plus 3 times 9. And I want you to see kind of where those numbers went. I took 3 and I multiplied it by g, and that's what I got here. And then I took 3 and I multiplied it by 9, and that's what I got here. And then whatever operation was in the middle, I carried over to this side, and I added them together. Now the crazy thing is it works for subtraction too. Let me get my example here. Alright, so let me show you an example in subtraction. So if I have 2 times 10 minus h, I can rewrite this as an equivalent expression. I can say 2 times 10 in parentheses, and then 2 times h. This is kind of just breaking that number down. And then what I do in the middle is whatever was in the middle of my parentheses. We were subtracting, so here I subtract. This is the distributive property. Welcome to the distributive property. It is very, very important. You're going to have more practice it in a minute though, so stay tuned. Okay, let's give you guys some practice. First, we're going to be just combining like terms using those properties. So this is going to look very similar to 7.7. So here we have 5a plus 8a minus 16. We're going to use properties of operations to write an equivalent expression by combining like terms. So if I choose to do 5a, whoops, sorry, where's the a? There we go. 5a plus 8a, I can go ahead and do the associative property and add those together now, which would give me 13a. And I still need to include my minus 16. And now I have here an equivalent expression that's a little bit more simplified, but it is still equal. So I like to write it this way, just so you can see that these are equal. They are the same. Both expressions would give you the same answer. So let's go ahead and give you a chance. Here you have a different expression. You have 7s plus 8t plus 10s plus 12t. Will you write me an equivalent expression, a simplified expression, by combining like terms? Go ahead and try it on your own. Okay, hopefully you tried it. I think you can probably do this one. So let's see how you did here. I can go ahead and, using the commutative property, I can rearrange these. 7s, I'm going to bring my 10s next. Sorry, those look kind of like 5s. They are s's. And then I have 8t plus 12t. And remember, the commutative property tells me I can move these numbers around when I'm adding. It doesn't matter. So now I have 7s. I'm going to add those together. That's 17s plus 8t plus 12t is 20t. Now I have two equivalent expressions. Here's my original. It's 8t plus 10s plus 12t. That's a long expression, but I can write an equivalent expression like so. Much more simplified. Okay, so these are the same expressions, just written in a different way. I really like to make the connection in my mind to fractions, because you guys know that with fractions we can write equivalent fractions and one of them's simplified and one of them's not as simplified. Like if we had 4/8 is equal to 1/2. 1/2 is obviously the simplified version, but they are still equal fractions. Same idea, except now instead of fractions we're working with whole expressions. This equal signs means that they are the same. This is a balancing symbol, showing this side is the same as this side. Hopefully that kind of helped clarify what we're doing here. Okay, now I told you we'd come back to that distributive property, so here's your chance to really understand how it looks in algebra. We're going to use the distributive property to write an equivalent expression. So here I have an expression, 6y plus 7. You'll notice right away there's no like terms that you can combine because we've got 6 on the outside, we've got y plus 7. What are we going to do here? Well, let's go ahead and rewrite this in the distributive property form. First, I'm going to multiply my outside number, my 6, times my first number on the inside of the parentheses. Now I want to point out, this distributive property works when it is multiplying by the parentheses. Because these are right next to each other, that means 6 times whatever's in the parentheses. There is an addition sign between the 6 and the parentheses. You can't use the distributive property. Hopefully that made sense. So 6 times y is 6y. Whoops, sorry. 6 times y. And then I'm going to have 6 times 7. That was supposed to be a 6. Told you guys it's late today. 6 times 7. And then I look back to my operation inside the parentheses. I was adding them together. So now I have 6 times y plus 6 times 7. Now here you'll say, Mrs. Twisdale, this is not a simplified expression. You're right. It is kind of more complicated, but they are still equivalent. So the original expression that I just wrote here, this is the original. It is equivalent to breaking it apart. And this will come in handy more later in like 7th and 8th grade algebra. We're not going to do a ton with it today, but it is important to know how to break this down into an equivalent expression with the distributive property and recognize that these are the same thing. That equivalent distributive property will give you those two equivalent expressions. So here's your turn to try it. looking back at your previous example problem and using the same steps, here's some different numbers, different variables, but I think you can do it. Write me an equivalent expression, not necessarily simplified, but equivalent using the distributive property of 2 times 9 plus k. Alright, hopefully your answer looks something like this. 2 times 9, and then 2 times k, and you added them together. Now, if you chose to write it like this, 2 times 9 is 18, plus 2 times k is 2k. That's totally fine. You can do that as well. Both are correct. And honestly, that's probably even a more simplified answer. So you can do both. It's all just talking about what are equal expressions. There's so many ways to write these expressions. It's important to know if what you've done is equal. Okay, I have a little division sign up here because now we're going to be pulling out a factor out of my expression. So use the distributive property to write an equivalent expressions. The instructions are still the same, but here we don't have the parentheses. We're going to work backwards. We have 12a plus 8b. So what I'm going to do is I'm going to look for a factor within my coefficients. 12 and 8 share a couple of factors. Their greatest common factor that they share is 4. 4 fits into both 12 and 8. So I'm going to work backwards. I'm going to say I'm pulling a 4 out of these numbers. If I pull a 4 out of 12a, it leaves me with 3a, because 4 times 3a equals 12a. Okay? And then if I, and I'm going to add, I'm going to pull a 4 out of 8b. Pull a little 4 out of there, that will leave me with 2b. And here is another equivalent expression to our original. That's my original expression. Here's my equivalent. Let's just double check our work. If I have 4 times 3a, that would give me 12a. And 4 times 2b, that would give me 8b. Look at that. It matches. So we did it correctly. So here is an equivalent expression. We're almost done. I'm going to have you try this one, and then there's one more, okay? So go ahead and try looking in this expression. Is there a GCF or a factor that you could pull out? I want you to just try it. Then play the video and see if you did it all right. Okay, 20b and 16c, the coefficients do share a factor. Again, our factor is 4. So I'm going to pull a 4 out. And if I pull a 4 out, then what's left in my parentheses, I have 20b. If I pulled out a 4, divided it by 4, I'd be left with 5b. If I divided 16c by 4, I'm left with 4c. And again, I'm dividing by 4. So then I have 5b plus 4c. And then let's check our work. 4 times 5b, switch colors here, 4 times 5b is 20b, plus 4 times 4c, which is 16c. Does it match our original problem? Yes, it does. That is our equivalent expression, would be right here. Of course, this isn't our equivalent expression down here. This was just us checking our work. That was the original expression. Hopefully you got that right. If you have any questions, let me know. Here's the last example, or the last try it problem. You have 30d and 18. Go ahead and see what factor you can pull out and make an equivalent expression with the factor on the outside of the parentheses. Okay. Taking a look here. Whoops. Sorry. What did I do? Okay. and drop my pen. 30D plus 18. 30 and 18 have a common factor. They have the common factor of 3. So I'm going to pull out 3 first. Or I'm going to divide it by 3. So if I take 30D and divide it by 3, it leaves me with 10D. Now I'm taking 18 from right here, dividing it by 3, and it leaves me with 6. So if I pull 3 to the side of my parentheses, it will leave me with 10D, add, plus, there's my plus sign, plus 6. Let's check our work. 3 times 10D, that was supposed to be an arrow, is 30D. And 3 times 6 is 18. Matches our original. But there is another way you could have done this. This is a perfectly fine expression. Another thing you could have done, though, is gone a little further and said, well, 6 is a greater common factor that we could have removed. Totally true. If you remove 6 instead, it would look something like this. 5D plus 3. That's another equivalent expression. Completely acceptable. What if you would have removed 2? Because 2 is a factor of D, or 30 and 18. If you removed a 2, you would have 15D plus 9. All of which are appropriate answers. So these are all equivalent equivalent expressions to our original expression. And it just said, write an equivalent expression. So any of those answers would have worked just fine. Hopefully you understood this lesson pretty well. If not, ask me questions. Feel free to work through the problems again. Make sure you have them in your notebook. And as always, use your notebook to help you on your appetizers and your homework so that you feel really confident in these operations. Thanks so much, guys. Have a good day.